and Clefatso. And Amelia, hello. I don't recall seeing your name before, but anyway, welcome to our lessons. Rabin, welcome. Okay, so guys, on the screen, as always, you will see a do now. So please get started on that while we're waiting for everybody. We've still got a few minutes to go. Hopefully everybody's got a notebook and a calculator and a pen, and you can start answering the questions on the screen. Hi, Untitled. And Zayan, hello, and Luke, welcome. Hi, Tatuka. Hopefully you got your cell phone sorted out. Okay, so as always, grade 10s, hi. Please get started on the do now. See if you can do 2 or 3, it's up to you. And then we'll get on with our lesson as soon as everyone's joined. Okay, so see, you've just joined too, Naileti and Sihle. Welcome, welcome. Get started on the do now, and we'll get underway in a couple of minutes. Welcome back on Tile. Hi, Daniel. Okay, so we're just getting started on the do now, like we always do, and then we'll get underway with our lesson in a couple of minutes. Hopefully this is super, super easy for you guys, just a little bit of practice with expanding products from grade 9. Hi, and Tapasang, welcome. And Nawazi and Ria Betswe, I'm so glad you guys are back. Please get started on the do now. Hope you've got everything with you that you need. Hi, Tatuka. Thanks for your message, Nolwazi. Hi. And Enhle, welcome to you too. Please get started on the do now. And we'll look at the answers quickly and then we'll get underway with our lesson. Okay, so let's get underway. Grade 10s, hopefully everybody that's going to join us has joined by now. I hope everybody's well and happy and healthy and fine. Just a reminder before we get started with the lesson, do you remember at the beginning, we said that there was a quiz. There was a quiz after the third lesson, and then there's a quiz again at the end. So just a little reminder to you to please go and do the quiz after the third lesson. It's not, don't worry about whether obviously we want to see whether you can pass or fail or whatever, but it's not about that. It's about how did you understand the work that's being taught? Are you keeping up? Are you managing? Because it's only when we get tested, it's only through assessment that we really get to see whether we understand or not. So please, 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 everybody needs to go and do that. I think you've got a couple of days to do it. You don't have to do it. I think it needs to be done by Monday next week, but I'll just double check with Tula again at the end. But I think that's the situation. Okay, so just a reminder to go and do that. It's on the app. And you should find it under the functions section. Okay, so let's have a look at what we were getting started on today. And I asked you to expand some products, all right, and calculate the answer to this. All right, so does anybody, okay, so Sihle, you can't hear me. I'm sure Tula will help us with that. Ma'am, you don't have the app. Okay, and Tabasing will speak to you about that at the end of the lesson, and we'll sort that out. You've got to download the Watobi app.
Sorry, Lee. Can I just disturb your lesson for a bit?
Sure.
Hi, Sihle, and I think Nosisa as well. You guys have not turned on you have not joined audio. So on the bottom of your screen for everyone else as well, just click join audio, and then you can be able to join the sound and be able to hear everyone. Okay, I'm done. Thanks.
Thank you so much, Tula. I don't know what we would do without you. Okay, so in Tabasing, we'll talk about the app at the end, but you've got to download it. You've got to download the Watobi app. It's part of the package together with the lessons. Okay, so now let's have a look at the first one. Is there anybody who's feeling brave, and of course it doesn't matter if you get it wrong, who wants to suggest an answer for the first one, for the green one? You can either unmute your mic or type into the chat. Even if it's wrong, doesn't matter. As long as you're trying, that's all that matters. Okay, so Inhlafatso, you've typed something. You said 2y squared plus 8. Thank you, Inhlafatso. Let's have a look. I'll move my green box out the way. And 2y squared plus 8. I got 8y. Did anybody else get? You can do the purple one with pleasure, Rabin. Absolutely. So they're there for you to try before we get started, just to sort of help get our brains in gear. In Tlafatso, do you know why it's 8y at the end? I got that. Good, Zayon. Well done. Good job. Okay, so it has to be 8y at the end because, well done, Nolwazi. Well done, because we're saying 2y times 4. So 2y times 4 will give us 8y. Okay. Any questions about that one? Everybody happy? Okay, so now the purple one. All right, so let's see what you guys did here. So Rabin, you said, can you do the purple one? I don't really know if I've given you enough time to try it. Do you want to tell us what your answer is, Rabin? You can unmute your mic or you can type in the chat. The choice is up to you.
Y squared plus 7y plus 10.
Beautiful. Well done, Rabin. That's exactly what I got as well. Y squared plus 7y plus 10. Excellent. Well done. Good job. Anyone managed to do the orange one?
I got to do it, ma'am.
Excellent. And what did you get as your answer?
5t plus 2.
5t plus 2. Let's have a look. Okay, that's what I got. I got 2 minus 5t plus 2t squared. Does that make sense, what I got? Because what I'm doing here, of course, is when I multiply two brackets together, specifically two brackets together, it's got a name in maths. Does anybody know what that's called when you multiply a binomial with a binomial? Do you know what that's called? There we go, on Theta, beautiful. It's called FOIL. It's called FOIL. And FOIL stands for firsts. So first times first. So 2 times 1 is 2. So that's correct. O stands for outers. So 2 times minus 2t is minus 4t. That's correct. I stands for inners. Okay, so this I over here is for inners. So minus t times 1 is minus 1t. So that looks good. And then L is for lasts. So the last term in the first bracket and the last term in the last bracket. So negative times a negative is a positive. Pardon me. 2 times 1 is 2 and t times t is t squared. Okay, so there's nothing else that's like t squared. So that has to come down and be part of my answer. Here I have two like terms. So I'm sitting at minus 4t on the number line. I move one place to the left. I'm going to end at minus 5. So there we go. That's why that answer would be correct. Okay, everybody happy with that, I hope. Let's get on with our lesson. All right, so now today we're going to be talking about a completely different function called the hyperbola. Who's done the hyperbola at school already? So what you can do, oh, good, Sihle, you can hear everybody. Who's done the hyperbola already at school? If you can just type in the chat and say me or not me, if you haven't done it. Who's done the hyperbola already? Okay, so Daniel, you haven't. Untitled, you have. Not yet. Enhle, okay. Okay, and Tabi saying you didn't understand. Nosisa, not yet. Okay, Ria Betswe, thank you. Thank you, Sihle. Okay, Naileti, you did, but you didn't understand it. Okay, that's fine. Okay, so there, Rabin, no, not yet. Okay, Sihle, yes. Okay, so there's there's a little bit of, I still don't get it though, fine on Thetile, not a problem. Okay, so what we're going to try and do is I'm going to try and take it really, really slowly then, because if this is something that some of you haven't seen, is it similar to functions? Yes, the hyperbola is a different sort of function. It's a different sort of rule. Okay, so yes, it's part of the functions section. So maybe that's actually a good place to start, Daniel. Let's start with the basics. Okay, so in grade 10, right? That's the first time. I'm just going to go over here on the side. In grade 10, this is the first time that you are truly sort of introduced to functions. Okay, and of course, last year was a horrible year for everybody because of COVID, and we missed so much school. So it's even harder for us to understand. So when we are in high school, there are going to be, well, when you get to matric, it would be 5 functions, but they're going to be 4 functions that you need to study. Okay, so the first one is going to be the straight line or linear function. And that is something that we should have done in grade 9, all right? So that takes the form. Does anybody know what the general form of the linear function is? Before I write it down here, does anybody know what it is? The linear function. You can type it or you can put it into a... Anybody know what the linear function... We actually had one... Yes, what, okay. What does f of x mean, Daniel? Do you know what f of x means? Yes, quite right, Nolwazi, that's the correct shape, okay? If you say no, Daniel, it's really cool. Don't worry, that's why we're all here, all right? So if you don't know what f of x means, f of x means y. So it's just a different way of writing y. So when we write y as f of x, we say y is a function of x. And the reason why we call graphs f of x or g of x or h of x or anything of x that we want to is so that we can draw them on the same Cartesian plane, and they've each got a different name. Okay, so the one will be called f, the other one will be called g, the other one will be called h, so that we can differentiate between them. Kind of like we've all got names, do you know what I mean? So people can differentiate between who we are. All right, so it's just a name, really. It all means the same thing. G of x, f of x, h of x, it means y. Y is output. Okay, so y is the numbers that we have on our y-axis. Okay, so that's the vertical axis. All right, so the linear function, sorry, I digress, takes the form y equals mx plus c. Does that sound familiar? And as Nolwazi said, these are straight diagonal lines. So either they slope up to the right or they slope down to the right. In the case of them sloping up to the right, their gradient given by the letter m is positive. If they slope down to the right, then their gradient is negative. The things that I'm saying now is this stuff that you've heard before, grade 10s. Am I telling you anything that you didn't know? You can type in the chat or you can unmute your mic. Okay. Then what we spoke about, you started learning about this today. Okay. All right. Well, hopefully all of this is going to make sense to you, Zayon, and everybody else. I'm just going to go super, super slow, and then hopefully nobody gets, you've seen this before, you did it at school. Okay, all right, good. I'm so glad. I'm so glad. So at least some of this will look familiar to you. Now, the quadratic function is what we had our previous 3 lessons on, okay? So that takes the form, if you guys remember, y equals ax squared plus q. Okay, so remember last time we were talking about the value of a and what that did to the function. So either our quadratic function, otherwise known as a parabola, that's the other name for it, it's called a parabola. Either it can be happy face or it can be sad face. So if it's happy face, then a has to be greater than 0. If it's sad face, a will be negative like that. So those are the first 2 functions that we learned about. Okay, do you recall we learned how to draw them, how to find the equation of them, and then we did application questions. So those are the sorts of things you're always going to be doing. You're going to be learning how to draw them, you're going to be learning how to find the equation, and then you're going to be doing application type questions. So now the next kind of function that we are going to learn about is the hyperbola. Okay, so where can I put this? Tell you what, let's get rid of this. And right over here. Okay, so theoretically speaking, all right, if all is going well and life is going according to the way that it should be, we should do the linear function. We should do that in grade 9. Okay, then when we get to grade 10, we expected to know the linear function, and then we learn the quadratic function. And after we've done the quadratic function, you will find that your teachers will go on and do the third kind of function that you need to know, which is the one we're going to talk about today, called the hyperbola. Hyperbola, like that. Okay, now in its most simplest form, the hyperbola also has a general equation. So just like I can describe a straight line by using y equals mx plus c, and I can describe a quadratic function using y or f of x or g of x equals ax squared plus q, I can describe the hyperbola as follows. Y equals a over x. Okay, now we can also add a q on the end. Just like we've got a q on the end over here, we can also add a q on the end of this. What do you think the q would do if I added it onto the end? Does anybody have an idea about that? Anybody who's done this before? If I put a plus q on the end here, what am I changing? How am I changing my hyperbola?
The shift of the graph.
Absolutely, absolutely. It's a shift of the graph. So either you're shifting it up or you're shifting it down. So if there is a q on the end plus q, this represents vertical shift. Okay, so that means shifting up or down. Okay, now, before we get into that, have you seen before grade 10s? It's something that you should have been exposed to in grade 8, where we talk about cross multiplying, right? So in an equation, have you heard that term before, where you cross multiply? You can put a yes or a no into the chat for me. Yes, you heard of cross multiplying?
Yes, ma'am.
Oh, lovely, thank you. Yes, you've
Yes,
heard of
ma'am.
that. Cool beans. All right, nice. Good stuff. Okay, because I didn't want to say something and then you guys are confused, but you should know what cross multiplying is. Okay, so when I cross multiply my hyperbola, I've got y is y over 1, all right? And on the other side, I've got a over x. So what happens is I multiply x and y together to get xy equals a. So what this means for you is that you are multiplying an x coordinate and a y coordinate together and always getting a constant number. Okay, so think about it like this, all right? Imagine we were lucky enough and we were at a school and we could go on a school trip, okay? And it cost 1,000 Rand to go. If one person goes on the school trip, they will end up having to pay 1,000 Rand. But if 2 people go on the school trip, then they can each pay 500 Rand. Can you see how 1 times 1,000 is 1,000? 2 times 500 is also 1,000, right? If 4 people went on the school trip, then it would become even cheaper for them. How much would each person have to pay if there were 4 people going on the school trip? Exactly, 250. Okay, so that would also give us 1,000, right? Let's do one more. Let's say we go all the way down. Oh, let's just go to 5. That's nice and easy. So if 5 people go on the school trip, what are they going to pay? Each person is going to have to pay
200.
200. Beautiful. Thank you so much. So can you see I am multiplying? Well done, Sihle, that's right. So can you see I'm always multiplying one number by another and I'm getting the same value. So now if I do what I'm trying to show you, let me just change the color of the pen, okay? Your X numbers, your inputs, is this group of numbers over here. These are the numbers on the x-axis. Okay, so these numbers over here, these are the numbers that go in. Okay, these numbers go in. All right. When we multiply it by this value over here, oh, let's get a different color. Red. These numbers are changing. First it was 1,000, then it was 500, then it was 250, then it was 200. These are the numbers that come out. And when we multiply them together, we get a constant value. Okay, so let me draw, let's see if that works. We get this constant value over here, which is 1,000. This is the A. So in other words, what I'm trying to explain to you, grade 10s, is that the hyperbola is a function that is made by multiplying x and y together and get A. This over here, you're going to multiply your x coordinates with your y coordinate, and you always end up getting A. What happens is that when we draw this, when we plot these points on the Cartesian plane, what ends up happening is this. Let me just clear a little bit more space. Okay. Let's use these same numbers as an example. That, okay. And let's get a set of axes. All right, so my apologies that my axes are not very good, but there we go. All right. So here is 1 going in. That's this 1 over there. Here's 2 going in. That's this 2 over here. Here's 3 going in. Okay, we didn't use 3, but it doesn't matter. Okay, 4. There's 4 going in. Here's 5. There's 5 going in. So now my number line, okay, it has to start at 0 over here, and I've got to get to 1,000 up at the top. So 500 is halfway in between, and 250 is halfway in between that, and 200 would be just a little bit smaller. So look at what happens, okay, when I plot x against y. Okay, so x1 times 1,000 gives me 1,000. 2 times 500 gives me 1,000. 3 times, sorry, I'm talking nonsense. 4 times 150 gives me 1,000. 5 times 200 gives me 1,000. What this makes, grade 10s, is a really weird looking curve. Now I'm going to try and draw this as best as I can. Like that. Okay. Not brilliant, but not too bad. That's what it looks like. And then it has a mirror image over here. And the reason for that, grade 10s, is because if I take -1 and I multiply it over here by -1,000, I'm still going to get that same point. A negative times a negative is still a positive. And if I have -2, sorry, beg your pardon, -2 over here, and I multiply it by negative 500. Negative 2 times negative 500 still gives me a positive 1,000. No, the line has to be curved. It's a curve. Okay, so the only one that's straight is the linear function. Okay, so the quadratic function is a curve, and this is also a curve. Okay, so we get this curve by multiplying x and y together. It gives us the same value every single time, except we don't write it as xy is equal to a, because we always write functions with y as the subject to the formula. So essentially what we've done to go from here to here is we have divided both sides by x. So y is equal to a over x. Now, the reason that I'm explaining all of this to you is to try and help you understand something about the shape, all right? When we multiply a positive with another positive, what sign does our answer take? So you can either unmute or you can put it in the chat. A positive times a positive gives us a
Positive.
a positive. Quite right. Absolutely. Absolutely. So can you see positive 1 times positive 1,000 is positive 1,000, and positive 2 times positive 500 was positive 1,000, and positive 4 times positive 250 was positive 1,000. But what else happens when I multiply a negative with a negative? What do I get?
Positive.
A positive as well, absolutely. So when I multiply the negative 1 with negative 1,000, I still get a positive 1,000. So I'm still getting the same pattern. And when I multiply negative 2 with negative 500, that's why I'm getting this dot over here. And negative 4 with negative 250 is going to give me that point over there. So that's why the hyperbola is a function, and then there is a mirror image. So in other words, this arm over here where I'm pointing the arrow at is a mirror image of that side over there. Okay, so when we multiply two positives together, a positive x and a positive y together, we're going to get the arm that is drawn in the first quadrant. And when we multiply the negative with a negative, we get a positive, and that's this arm over here that's going to be drawn in quadrant 3. No, Sihle, when you multiply a negative with a positive, then you get a negative. Okay, so let me just change my color. When you say you add, Sihle, what do you mean exactly? So just coming back to this. So if I've got a positive times a negative, I get a negative. And if I have a negative times a positive, I also get a negative. So if I have a positive x, correct, that is correct, Sihle. Okay, 100%. When I multiply a positive with a negative, I get a negative. Then one arm of the hyperbola would be drawn in, that would be in quadrant 4. And if it was a negative x and a positive y, then it would be drawn in quadrant 2. So in other words, your hyperbola, let's go back. Just move over a little bit. Whilst it can be drawn in quadrant 1 and 3, which is what I've just shown you right now, your hyperbola can also be drawn in quadrant 2 and quadrant 4. Have you heard quadrants? You've heard the word quadrant before? You know what I'm talking about when I talk about quadrants? So, yes?
Please explain, ma'am.
Please explain. Okay, all right. So the Cartesian plane, your set of x and y axes, these are really just two number lines. a horizontal one, which is the x-axis, and a vertical number line, which is the y-axis, and they cross over one another when they both equal 0. Because they cross over one another, it creates 4 places or regions, right? So this region over here is always called quadrant number 1. This is quadrant 1. And for some reason, they use Roman italics, but you can just call it quadrant number 1. And in quadrant number 1, x is positive and y is positive. This is quadrant 2, always, always, always. Okay, so for some reason, we start at the right and we move over to the left. So this is quadrant 2. And when we go into quadrant 2, what happens is that x changes from being positive to being negative. So numbers start to get smaller. So in quadrant 2, x is negative and y is positive. This part over here, this is called quadrant 3. And here, y also changes its sign. So numbers start getting smaller. Okay. Why does it change? Because the y-axis is a number line. It's a number line. Okay, so 0 is in the middle. It's just vertical. So 0 is in the middle where the big pink dot is. And then above there, that would be 1, and then 2, and then 3, and then 4, and then 5. And it goes on in both directions forever and ever and ever. Does that make sense in Tabaseng why it changes? Okay, it's because one unit smaller than 0 is -1. Naileti, good question. All right. Naileti says, in quadrant 4, y is negative and x is positive. Perfect. 100%. That's exactly what I wanted to say. All right, good. Excellent. So here we've got negative x and negative y in quadrant 3. And as you said, Naileti, when we get to quadrant 4, no problem in Tabaseng. I mean, this is so important that you understand this because functions and so much of our maths is based on this, and it's we can't do so many things if we don't understand this. So I'm only too happy to explain it to you. So quite right, x is positive and y is negative. Okay, so what do you notice, grade 10s, is the same about quadrant 3 and quadrant 4? What's the same? So either you can unmute or put it in the chat. What's the same about quadrant 3 and quadrant 4?
Y is negative on both sides.
Beautiful. Okay, that's it. You nailed it. Okay, so y is negative in both. So in other words, below the x-axis, that is where y is negative. Okay, below the x-axis is where y is negative. What do you notice is the same about quadrant 1 and quadrant 2?
Y is positive.
Y is positive. Exactly. Okay, so above the x-axis, y is positive. Okay, so y changes sign when we are above the y-axis compared to when we are below the x-axis. Okay, so above the x-axis, y is positive, and below it's negative. What do you notice is the same about quadrant 2 and quadrant 3? What's the same?
Negative on both sides.
X is negative. Indeed. Indeed. And what's the same about quadrant 1? Quite right, Sihle, yes. What's the same about quadrant 1 and quadrant 4?
X is positive, yes, ma'am. X is
Beautiful.
positive, ma'am.
Quite right. 100% X is positive. Okay, so we can see these 4 areas each have a chance where X and Y change their signs. Okay, and that's because X and Y are these numbers. These are the X numbers that I'm just busy drawing a circle around. Those are the X numbers. Okay, and then the Y numbers, the outputs, as we like to call them, I'm drawing purple circles around them. So these are outputs. So they're positive up here and they're negative below the x-axis. Okay, so that's really important for us to understand. When we get this, then we understand why when we have a positive x multiplied with a positive y, that we end up with a positive a value, and we end up with one arm of the hyperbola over here. Hopefully, I hope that this also makes sense that when we have negative x times a negative y, we end up with a plus a value, and that's why the arm also ends up over there. If that makes sense to you now, will you give me a thumbs up? Thanks, Sihle. Cool, Rebets, where cool they are. Lovely. I hope this is making sense. I'm sorry, we've spent a lot of time talking about the basics, but thanks. Thanks, Nolwazi. Thanks, Tandeka. Okay, so now I'm just going to quickly change my color, all right? And then I'm going to draw on the same graph, although it probably is a little bit confusing by now, but does it make sense? Now I'm looking in quadrant 2, okay? Look at quadrant 2. You've got a negative x times a positive y. What does the sign of a have to be? Can a be positive? No ways, because, say again?
No, ma'am, it has to be negative.
It has to be negative, quite right. So if I've got a negative x and a positive y, that's this quadrant over here. So that's that arm of your hyperbola. All right. And then that will also be reflected into the fourth quadrant, because here you've got a positive x times a negative y. And again, we would end up with a negative a. Is everybody happy with that? And I'm going to show you what it means when we actually look at the function. Are you guys okay with that? Thumbs ups?
Yes,
Or
ma'am.
smiley? Cool, thank you. Nice, awesome. Thank you, thank you, thank you, thank you. I love it when you give me feedback, okay? Because all I want you guys to do is to understand it. Wow, what a story we've been on. Okay, so we were first listing all the functions that we were going to learn about. Cool, Nizol, cool, Nolwazi. I'm so pleased. And then we were talking about, good. We were talking about the hyperbola. And the reason that I went on this long story to explain this to you is so that we get back to this point over here. Now, what I'm going to do is let's forget about Q for now. All right, forget about Q for now. Doesn't matter. Okay, you guys know that it means shifting it up and shifting it down, right? So here is your X. You see the X down at the bottom there. So that is the numbers on the horizontal axis. The Y over here, those are the numbers that are on the y-axis. Okay. Now, either A is positive or A is negative. This is what I was getting to over here. So A, like with the parabola, remember when A was positive, we had a happy face. Okay. When A was negative, we had a sad face. So just like A affects the shape of the parabola, A affects the shape of the hyperbola. When A is positive, your hyperbola is drawn in quadrants. Anybody want to have a go at that? Quadrants, which quadrants? Which two quadrants? I'll explain to you now, Daniel.
Ma'am, is it the first one?
Beautiful answer.
Fourth one. Fourth.
And the third.
Third one. Sorry.
Third one. Okay. So 1 and 3 go together. Okay. I hope that's making sense. If A is negative, then our hyperbola is drawn in quadrants. Does anybody know?
2 and 4.
Beautiful. Oh, wow. I'm so happy. That's great. Okay. And Tab is saying you don't get me. I'm going to show you now with an example what I mean by that. Okay, we're going to sketch one. Daniel, the reason why we don't do the y-intercept in grade 10 is because the y-intercept is a grade 11 concept. Okay, so you will do it, but you'll only do it next year in grade 11. Okay, because functions are new and they're so difficult, we don't throw everything at you all at the same time. Okay, so let's just see if we can make sense of what's going over here. Okay, so in Tabaseng, all right, when you said you don't get what I'm saying, I'm hoping now you'll understand what I mean. So in Tabaseng, or anybody else, it doesn't matter, when you look at this function that I have given you over here, all right, so it is the line y equals -4 over x plus 7. What is the value of a? Does anybody know? You can put it in the chat. You can tell me.
-4.
Beautiful. A is equal to -4. Good, Sihle. Okay, excellent, excellent, excellent. It's -4. So which two quadrants am I going to draw this hyperbola in?
The second and fourth one.
Beautiful. Quadrants 2 and 4. Now you need to know that before you start drawing it, don't you? Because otherwise you're not going to know where to put it. So that's why understanding and knowing what the sign of A means is so important. All right. Now we are going to draw this. Oh, we've got 15 minutes left. Okay, let's have a look at this one just very quickly. Okay. Now, I didn't pick a very good question here. Okay, so now what I'm going to do is this. All right, let's be flexible. All right, I'm going to get rid of that. Ignore that. Okay. What is the value of A in G of X? So either you can unmute or pop it in the chat.
2, +2.
+2, beautiful. It's +2. Excellent, everybody. Well done. Nolwazi, Sihle, Nosol, perfect. So in which two quadrants will this hyperbola be drawn? Yes, in Tab is saying it's 2. This number over here, that's where the A is. Okay, the A is on top of the X. So which two quadrants will I draw this one in?
1 and 3.
1 and 3. Beautiful, Sihle. Yes, well done, guys. Awesome. Okay, so now let's go back and sketch this function. Okay, we haven't had a chance to talk about the asymptotes yet. And I'm not sure if we're going to get a chance to do that this lesson. But anyway, it doesn't matter. We're just going to be flexible. Okay. Because this graph has got A as -4, we know that it has to be drawn in quadrants 2 and 4, right? But what's happened is that it has also been shifted 7 units up. Okay, so because it's been shifted 7 units up, if it was just the graph of y equals -4 over x, then we would have an x-axis and a y-axis. And we would have one arm of the parabola over here, sorry, hyperbola over here, and we would have the other arm over there. But now we've taken what we've drawn and we've moved it up 7 places. So now my x and y axes, they don't move. They set in stone. They're going to stay where they are. There's x, there's y. But what's going to happen to my functions? Every single point has to move 7 points up. So in other words, my hyperbola, instead of it being drawn, oh, shame, Katlejo, You've missed quite a lot this lesson, I'm afraid. We'll see if we can, hopefully you can catch up. All right, so moving it 7 units up. Now it's going to be situated over here and over there. So if it's not moved, if Q is equal to 0, it hasn't been moved up or down. But if Q is another number, then it's either, if this number is positive, it means that the graph has been shifted up 7 units. If this is a negative over here, then it means that the graph has been shifted down. So now we have this important point over here. That's called an, does anybody know? What do I refer to this point as? It's got a name. You can unmute or type. Do you know what this pink point is called? It's called an X-Intercept. Is that a word that you guys have heard before? You should have heard the word X-Intercept before. Yeah, that's true, Kakeho. All right. Okay, so you've heard X-Intercept. On Thitile, there's a rule when it comes to functions, all right? And it doesn't matter which function you're working with, whether you are working with the linear function, whether you're working with the parabola, the quadratic function, whether you're working with the hyperbola. The same rule applies for the X-intercepts and the Y-intercepts. Yes, you would have to draw the dotted line, and that would give you 1 mark. Okay, would give you 1 mark. Okay, so what is the rule for finding the X-intercept? You can type or let me know. It's the same rule for all functions. We have to let, does anybody know? We have to let y be equal to 0. And that's because, quite right, 0. That's because it does not matter where I am on the x-axis. Y will be equal to 0. Remember, these two lines cross over one another, where both of them are equal to 0. So if you are sitting on the x-axis, y is 0. So sitting on the x-axis means y is 0. Sitting on the y-axis means x is 0. So that's why the rule is if you want to find the y-intercept, you have to let x be equal to 0. All right, so now let's work out what this x-intercept is going to be. We're working out the coordinates of this point. Remember, we always write coordinates, x first and y second. So now I want y to be 0. So this y over here, I'm replacing with 0.
0.
Good, well done. Over x plus 7. Now what has to happen, guys? What has to happen to this plus 7? Where is it going to go? Can anybody tell me what to do with plus 7? You move it to the other side. Beautiful. Yes, 100%, quite right. And when I move it to the other side, is it still going to be plus 7?
No, ma'am, it becomes negative 7.
You guys are so good. Well done. Excellent. All right, so when I move it over to the other side, it becomes negative 7. That means negative 7 over 1 equals negative 4 over x. Remember, we were talking about cross multiplying. Okay, so this is where you're going to use it. This is where you're going to use that method of cross multiplying to solve for x. So now you are going to cross multiply the one at the bottom with the one at the top, and the other one at the bottom with the other one at the top. So when I multiply x with minus 7, I end up with negative 7x. And when I multiply 1 with negative 4, I end up with negative 4. Now we really are in a place where we've been many, many times before when we're solving for x, right? So now the $1 million question, what do I have to divide both sides by?
Divide both sides by negative 7.
Beautiful. Oh, that's beautiful. Well done. Good, 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 good. By negative 7. So divide by negative 7 on the left, divide by negative 7 on the right. And that means that -7 divided by -7 is positive 1x. And again, look here. Look, here's our rules with dividing. So our rules with dividing are the same as the rules with multiplying. When I divide a negative with a negative, I end up with a
Negative. A positive.
a positive. Okay, so just like a negative times a negative is a positive, a negative divided by a negative is also a positive. Okay, so now we've worked out, all right, the coordinates at this point over here. All right, we've worked it out that it's 4/7. It happens to be a fraction. That's okay. Can be a fraction. It doesn't matter. It's not always going to be nice whole numbers for us to work with. All right, and when you are in grade 10, the things that your teacher will be looking for, okay, this will be, drawing a graph like this will be out of 3 marks. And the 3 things that your teacher is going to be looking for, I'm going to write here in red for you. Number 1 is shape. And by shape, we mean that you've drawn it in the right quadrants. Okay, so the word shape means that it's been drawn in the correct quadrants. The second thing that your teacher will be looking for is that you've got the X-intercept correct. Okay, so that's this calculation over here. All right, second mark. And the third mark, now this is the thing that we haven't spoken about, and I've got 5 minutes to do it in, and I hope that I'm going to be able to finish. The third mark, grade 10s, is going to come from this. Okay, so Nizol, you know which quadrant to draw it in depending on the sign of A. Okay, so if A is positive, Nizol, you draw in quadrants 1 and 3. If A is negative, you draw in quadrants 2 and 4. Always, 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 always. That's a rule. Okay, that's what we were talking about earlier. So the very last thing is this weird word over here. Okay, and this is the first time that we come across this in a function. So linear functions don't have asymptotes. Quadratic functions don't have asymptotes. This is the first place that we find an asymptote. Does anybody know what the word asymptote means?
No, ma'am.
No. Have you learned about it, Naileti? Okay, so if you've done this function, your teacher would have said the word asymptote. But if you haven't done this function, then you wouldn't know. But at least now, when your teacher does tell you, it might be a little bit easier for you to learn. So an asymptote is a very special line in maths, okay? It's a line, excuse me, that cannot be touched. It's a line that your function cannot touch. A line such that the distance between the curve and the line approaches 0. Yes, Sihle. That's a very good way of being able to put it. Absolutely, right? So it's a line that your function cannot touch. Now, you have to learn, right, that this value over here, we're going back up to this, okay? This value over here, this +7, the number on its own, this 7 over here, oh, that was a plus. That is your asymptote. Okay, so now when a number was on its own in the quadratic function and in the linear function, it meant something different. In the hyperbola, the number on its own is your asymptote. Okay, so in other words, the line y equals 7 is the horizontal asymptote, an imaginary line. Absolutely. Okay. So now when we want to draw this, I mean, I know I've already drawn it, but when you are drawing a hyperbola, okay, let's just finish this off. Oh, time. Okay, so when you are drawing a hyperbola, we're going to draw the same one that we've just drawn. The very first thing you draw, grade 10s, is the hyperbola. So if they are saying to us, we need to draw the graph of y equals -4 over x plus 7. This number at the end is your asymptote. Okay, where will y be equal to 7? Well, it'll be somewhere up here, maybe there. Maybe that's where y would be equal to 7. So it is a horizontal line, and they generally draw it with a dashed line. And you've got to label it. You've got to say that that is the line y equals 7. The first thing that you have to draw. Remember, we worked out the x-intercept. We worked out that the x-intercept was 4 over 7. And we also looked at the value of -4 because that told us that it had to be drawn in quadrants 2 and 3. So just to finish this off, grade 10s, here is our one arm of our hyperbola. There's our x-intercept. We have to label it x first, y second. Our second arm, grade 10s, has got to be a mirror image of the other one. So in other words, you've got to just practice drawing this. It needs to be wow, that's not a very good mirror image. It needs to look like that. Okay, and that's what your hyperbola will look like. Shape, x-intercept, asymptote. Okay, that's what your teacher is going to be looking for. All right, so just very, very quickly, does anybody have a question that they want to ask? How are you feeling? Is this making sense now? Is this a little bit better than it used to be? If it's not, then don't say yes. You can say no. I'm not going to be offended. Does this make more sense than it did before? Cool, Kelebachile, I'm glad. Anybody else? It's becoming clearer to me now. Okay. Okay, David, all right. Not a problem. Anybody else got any feedback? It does make more sense. Okay. Yes, Nasisa, practicing this is really important. Okay, so Tula, our mentor, is going to address us now, and he's going to tell you where on the app. Oh, it's a pleasure, Sihle. I'm so glad. I'm glad, Naileti. You're right, Zayon. The more you practice this, the easier it'll become. Okay, so Tula is going to show you where you can go and practice this on the app now. Okay, so if you don't have the app on your phone or on your computer, you've got to get it.
Hi, grade 10s. Thank you so much, Lee. Can we all just clap hands and just appreciate Lee's wonderful lesson and just the patience, and this was wonderful. And thank you to you guys for sitting throughout the lesson. And it's really great because it's all the same names and faces, so that's really nice. And we've really pushed so much. I mean, it's amazing to see when you think that we just finished our 4th lesson now. That's really incredible. We by no means we know closer to finishing, because we still have a number of lessons for functions, and we still have, of course, other topics to cover, but we still have covered quite a lot of content, so that is amazing. Remember that our next lesson is on Tuesday, so the 10th of August, and we'll be continuing with the hyperbola and just finding equations and applications. So make sure you come back, just so your knowledge is built onto each other and you don't have gaps, so just make sure you come back. And just on the app, if you go to the app and go to pick a topic on functions and relationships, just click there, And then under that, there'll be Hyperbola, and then just click there, and then you'll be able to find everything related to hyperbolas. And I mean, yeah, remember, it's really just about practicing. You know, we have our leaderboard, of course, happening next week, but it's not about that, about trying to win the leaderboard. It's just about you practicing and making sure that you solidify your own knowledge and learning. And yeah, otherwise, I'll see all of you guys next week. I hope to see all the same faces. It's great seeing you all. Thank you to everyone who has their video on. Daniel, thank you very much for having your video on the whole time. I would encourage the rest of you guys to have your videos on. Nosisa, who else am I missing? I don't want to miss anyone. Untitled. Yeah, just you guys, thank you very much. And
you guys
yeah,
are
just
wonderful.
another thing to note for next time. Yes, definitely. To note for next time when you come in, remember that you need to click on the bottom left on your screen. You need to click join audio, and then it's going to ask you if you're using cellular or Wi-Fi, and then just click whatever is relevant to you, and then it's going to allow you to be able to hear and also speak to us. Okay, so we'll see you guys. We'll see you guys next week. That's it for this lesson. Goodbye.
Bye, everybody. Well done.